Welcome to this presentation on Radiometry and Photometry, part of OSRAM Opto Semiconductors LED Fundamentals series. In this presentation, we will define the terms radiometry and photometry and discuss important photometric concepts. Radiometry is the field which deals with the detection and measurement of radiation across the full electromagnetic spectrum, including ultraviolet, visible, and infrared radiation. Photometry is concerned only with the visible portion of the spectrum, from about 380 to 780 nanometers. The table summarizes the most common radiometric and photometric quantities. Radiometric power is converted to luminous flux via the integral equation. V lambda is the spectral response of the human eye in daylight, otherwise known as the photopic curve. The unit of luminous flux is the lumen. This slide shows graphically the radiometric spectral power distribution, P sub E, multiplied by the photopic curve V lambda, by taking the area under the resulting P sub V curve and multiplying by the constant K, the luminous flux in lumens is calculated. Solid angle is the three-dimensional analog of an ordinary angle. In the figure, the edge of a circular disk, the bright red circle, is projected to the center of a sphere. The projection intersects the sphere and forms a surface area A. A solid angle is the area A on the surface of the sphere of radius r divided by the radius squared. The units of solid angle are steradians. Note that it is a dimensionless quantity. Projected solid angle takes into account the projected area when the viewpoint is other than the center of the sphere. The element of solid angle is shown in red. The area of projected solid angle is shown in blue. As an example, the projected solid angle for a cone of half angle alpha is calculated. The most common photometric quantities are shown in the table. We have already discussed luminous flux. Luminous intensity, or just intensity, is light in a direction. The units of intensity are lumens per solid angle, or steradians. Note that intensity does not depend on measurement distance. The next quantity, illuminance, is light falling on a surface, with units of lumens per area. Finally, luminance is light from a surface in a direction. The units are lumens per area per solid angle. It is the perceived brightness. A Lambertian source is defined as one in which the brightness, or luminance, is independent of angle. In other words, the off-axis luminance is the same as on-axis. Such a source has an intensity versus angle profile that falls off as the cosine of the angle. Historically, many LED sources have had nearly Lambertian beam distributions, simplifying certain calculations. Take the example of calculating the luminous flux within a certain cone angle. Substituting the intensity distribution of a Lambertian source into the equation makes the integration simple. For a so-called Lambertian LED, the total lumens is about 3 times the on-axis intensity. Thank you for viewing this presentation by OSRAM Opto Semiconductors.